matched pairs design. The matched pairs design is a method of matching subjects or the people used in an experiment to produce the most accurate results. Because a lot of times we want to have a simple random sample or a completely randomized experiment. But there are some times where not having everything be completely random is better than having everything be really random in an experiment. So we use a matched pairs design to make our sample groups in an experiment more similar than if we were to use a simple random sample. The matched pairs design allows us to get more accurate results because we will have similar subjects or people undergoing the experiment in each group, so we can see how certain things affect similar people. We have a bunch of different methods of experiments that would be considered a matched pair design. So in some, two subjects are paired up. A lot of times people use twins in an experiment because they're most similar and share the same DNA, and the pairs are then randomly separated into two groups to ensure that similar people are represented in each treatment group. Another way to have a matched pairs experiment design is to test a before and after effect of an experiment on one individual, one animal, one plant. You get the gist. A third experimental design that can be considered a matched pairs design is when we test two different treatments on one individual, and that individual kind of serves as their own pair and their own control. First example is about a school that wants to see how well a new math program is working on students. So every student is given a pretest to see where they stand before the program is given to students. The school wants to split the students into two groups. One group will take a regular math class and the other will use this new program. So we want to explain the best method of creating a sample so that the school can get the most accurate results. In this case, we would use a matched pairs design. And the way we would do that is we would match students up in pairs who have the most similar score on the pretest. This way, you can have students that are similar to each other in both the group that doesn't get the program and the group that does get the new math program. So at the end of the 4 weeks, all students would be given a new math test and the difference of the scores would be recorded. And using a matched pairs design, we can be sure that the two groups have students that perform equally well to someone in the other group. If we were to randomize the whole sample, there would be a chance that maybe the best math students in the school would all be in the group that are using this new program, and that would maybe skew the results in a way where it would be inaccurate and the school would think that the program is better than it is. But if you have equal students in both groups, using the matched pairs design, the school can get the most accurate results. A second example is about a drug company that wants to test the effectiveness of a new cold medicine on patients. The company has 500 subjects who are complaining of a cold. We want to describe the best way to split the patients into the two groups receiving the medicine or a placebo in order for the company to get the best results about the medicine. So to make sure each group has subjects who suffer from the same symptoms, we would pair the 500 people into 25 pairs, and those pairs would be determined in theory by age and gender, but most specifically about people that suffer from the same symptoms. This way, we can see two people that have similar symptoms of a cold, hopefully the same type of cold, and see if their cold is affected better by this placebo or by the medicine. So by pairing the people up, we can see how the medicine is effective in the same type of cold, and we can get the most accurate results. Example 3 is about the infamous picture of the white and gold and blue and black dress. So a lot of people saw that dress differently, and scientists want to settle the disagreement over the color of the dress, and they want to see how different people perceive colors based on lighting and the saturation of the picture, because that was said to have been the reason by why people see the dress as different colors. So we have 50 sets of twins in this study. I want to know how we should split the subjects into sample groups. And what we would do is we would pair the twins together and then randomly assign twins to be in different sample groups where each is shown a picture with different one high saturation, one low saturation, and each sample group would be given different stimuli and asked what colors they see and how they perceive certain pictures. And by splitting up twins who had the same DNA and in theory see the same things, we would be able to decide how people perceive certain pictures in this case scenario. So as you can see, matched pairs designs are a great way to split up sample groups so that we have equal people or equal groups represented in each sample, and they're often used so that experiments can be more accurate, and in some cases are better than simply randomizing the entire experiment.